and colleagues. My name is Valdo. I'm a student from chemical engineering. I'm here to talk about Bruce vinegar and acetic acid. Interesting presentation. The whole vinegar is arising from French items, which means vinegar or Acetic wine. Although it's not produced by wine, but not a made of brand such as some fries. Vinegar was one of the first products of spontaneous fermentation used by the man on food. And we might say its formation takes place spontaneously because of an effect in the wine production. So in the days of today, more than 70 years of the world production of acetic acid is obtainable some methodology of methanol carbonization. And the macerator and the captive process such as development in the days of today, it still remains as the most efficient method for acetic acid production. The purpose of my presentation today is to explain about the vinegar and acetic acid production, covering theoretical and practical aspects in implementation of production system in an industry and housemaid, and to identify some of the processes used in conversion of metal prime to obtain vinegar in days of today, such as many times ago. Outline of my presentation is based into 4 parts. First, I'll talk about the macerator process. After that, I'll look at captive process and illustrative flow diagrams of methanol carbonization process. And finally, I'll describe production of acetic acid, of oxidation of acetaldehyde. Starting presentation, I would like to start talking about the macerator process. So the catalytic cycle, it starts by oxidative process, on which the methyl iodide is incorporated into rhodium carbonyl the iodide. So because rhodium, it has a low orbit of the low energy, it has a capability to receive the iodide in the methyl group. So the methyl of group B, it migrates to the carbonyl neighborhood, so producing acetyl, and the carbon monoxide is inserted into and to produce the acetyl the same. So in the final process, it consists in the regulative elimination, on which it set free the acetyl iodide, and acetyl iodide reiterates with the water and producing with the reaction Mario producing the acetic acid. So to still continue the presentation, I'd like to speak about the captive process. So the captive process, it's similarly with the macerator process. So here the iridium catalyst is used in conjunction with the iodide catalyst as more reactive substrate than methanol indicative catalytic cycle. So here the main advantage of this process lies in the stability of the iridium complex, which is larger than iridium. So the other advantage is reduced formation of by production of the security yield in relation to carbon monoxide consumption. So going up to the illustrative diagram, in the later diagrams we have here the process on which in relation to the dynamic process the metal prime, the carbon monoxide, and the ethanol, so methanol, is continually introduced into the reactor. In the compartment, which is the compartment, is going to react in the presence of the catalyst system, radium and iodide anion within 180 degrees Celsius and 3 to 30 atmosphere to form acetic acid. So the reactional mixture goes to the flash tank too. On that compartment, the reaction it occurs the reduction process makes that the most of the volatile component being vaporized, including the acetic acid, whilst the catalyst remains partial of the carbon monoxide and interfere in the stability of the radium compound, occasioning the loss of carbon monoxide binder and formation of insoluble species such as rhodium iodide 3. That's what it took place here. And concomitantly, the volatile mixture follows it follows through the exit at the top portion of the tank to a distillation column 3. In that column is made a separation of a weak impurity which are most volatile, such as methyl iodide and methyl acetate. In column 4, meanwhile take place the water removal. In the last column, the heavy impurity is removed. The less volatile, such as propionic acid, in the ratio level. First, it is necessary that the methyl alcohol get transformed in the most reactive substrate of that reaction of the catalyst occur. On this substance is in which has iodide as hydrogen iodide works as activator reaction with methyl alcohol in about the bimolecular nucleophilic substitution SA2 producing methyl iodide. So here also it occurs. So we produce what we have the acetic acid. So also it occurs the recycle here, and it goes here and also back on the start component 1, and we have the extraction gas. So into here also this process can still continues, and it goes also to produce the acetic acid. And still continue the presentation. Let's talk about carbon here, how to produce about the acid using acetaldehyde. So what happens here? For first, we have the calcium carbon. It's hydrolyzed with the water, it's producing alkane, and with calcium hydroxide here, and the same the alkane here. It's hydrolyzed with the water in the presence of the mercury too, and producing aldehyde. So the aldehyde is oxidized and producing acetic acid. So and also alkane here it's oxidized lead chloride or copper chloride as a catalyst in producing aldehyde, and also the aldehyde is oxidized in producing the acetic acid. And also we can use methanol alcohol as I explained as the process industrially reacting with carbon monoxide. It reacts in producing the acetic acid. So still continue with the presentation, concluding it, summarizing the domestic process and oxidation acetyl methanol carboxylation process to convert methyl prime to vinegar, essentially except it depends to the process, and secondly methyl prime region to region, because some regions depends to the other of methyl prime use. So finishing and thanking, I'd like to say, and to convert alcohol to vinegar, there's a way that takes place. For example, you invited in the party, and you got there, and you find some commemorative and fine beer that is to drink, you feel it tastes like vinegar. You get standard, and you wonder how it tastes vinegar. If it's wine, I will serve it. So I will explain more or less specifically what happens. The wine contains a coke, and after some times the coke ages and allows air to enter the container. The wine contains alcohol and air contains oxygen. So the oxygen of the air is reacted with alcohol. It's produced in vinegar. It's how it's tasted. So grateful for intention dismiss it. It's by learning to do what one should learn to do. Aristotle and other, we are not a system made for hard. We are channels made for channel. A Bill. So inviting question. If anyone has question, I'll be pleased to answer them.